So now today we start sinus के method. Sinus के methods, okay. Nested theory. I think this class is I think 8th or 9th class है. Oh, please like and share my videos for more subscribers. Okay. So now let's we start. So this type of given function, okay. This type f of x is a given here, x minus a1 and power is k1. Here power is k1. Here we take power is k1 into x minus a2, power is k2 into dot dot dot. This one is multiplication up to x minus an. Here we take n minus 1, okay. One extra term we get n minus 1, then power is k n minus 1 into here in multiplication x minus an and power is kn. Here k1 comma k2 comma dot 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 kn minus 1 comma kn, all are integers and a1 a2 dot 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 an all are real number, okay. Then how we find sinus scheme means, if here how we find, if this expression, this is a expression, first in a case suppose f of x is greater than equal to 0, and suppose either this here given f of x less than equal to 0, okay. Then how we assume the sign on real line number? If here given greater than equal to 0, then we take positive interval, and if here given less than f of x is means our expression is given in less than equal to 0, then we take negative interval only, means this is the solution, only we take negative interval, and in this here we take positive interval as a solution. So now proceed how we take. So firstly we find the roots. So how we find the roots? This is firstly we draw a real line number. This is a real line number. This side minus infinity, and this side is a plus infinity, okay. What happened here? This side is a plus infinity. Now from here we see from these factors, these are all factors, and here one condition here is given. Suppose this type, here is one condition is given here. Condition is, what happened? Why not change here sign? Here one condition is given, this type a1 is less than a2 is less than a3 less than dot dot dot, these ones are less than an. This type condition is satisfied also, okay. This type. So a1 is a less number, so here we start a1 a2 and a3. This type we take, and this side is an minus 1 and this side is an. Now firstly in the rightmost put here plus signs. In the rightmost interval an to infinity plus infinity we take positive interval, and here we see in here exponent of an is, what is the exponent of an? Exponent of an means this factor, an for this factor, an minus for this factor, and a1 this one, and a2 this factor here, okay. If n to the factor exponent is a k, for this one is factor is kn. If here what sign here we put? If firstly we see exponent of this k n, if even, then here stay the sign, means in the condition this type we write. If in a rightmost, firstly we write rightmost, in rightmost interval in rightmost interval we take here is a positive sign. In the rightmost interval we put positive sign. Okay, positive sign. Then in the second step we take if exponent of an is k, if kn is even, then not change here sign, means plus to plus here. Okay, but kn is even, then sign is stay, sign is remains stay. Means not change, but but if kn is odd, okay, odd, then sign is changed, okay. That means here is from positive to negative, this side is a positive now, then we take here negative, means here we note that this type, if k is odd, if k is odd now, this side is k is odd, here suppose this type, this side is a positive, then here we change sign negative. And now we take here in the second condition similarly, for root a n minus 1 we put sign. Okay, if kn minus 1 is even, then sign not change, means remain stay, not changed. But here put comma na, here we put 1 comma, if kn minus 1 is odd, then sign is changed, means here you understand, try to understand from here, kn minus 1, here exponent is kn, if here is this k is even, then sign plus 2 plus not changes. But if kn is here, kn is odd, then sign from positive to negative sign is changes, means positive to, then here we take negative sign. But here similarly apply for kn minus 1 root and all other roots. Okay, and so on. If this sign is this kn minus 1, means exponent of a to the power a n minus 1 term, means this exponent power of this one, means this power of this one is even, then sign is not changed, and power of kn is even, then sign is not changed. But kn is odd, then sign is changed. And here kn minus 1 is even, then same rule follows. Okay, same time for all factors, this one and this one, all factors apply for same rules. Okay, so this rule you write on your notebook, and now and so on in the same way, and so on for all factors, okay, all factors, okay. Now here we take which solution we take for demanding on the expression. If given in the solution, now we take in solution we take positive interval if f of x is greater than equal to 0, then we take positive interval. But in the second condition we take negative interval. If f of x is less than equal to 0, then we take this. Now we take some questions for more clarity how we solve inequality question, okay. First question is here 1 point. Before taking questions, some here given not point. So firstly note down points here. Not point you note down for directly solving inequality. Here given some tricks. If this type given here, x minus a, x minus b, if this is less than equal to 0, then we write directly solution as x belongs to a to b open interval. That means for this one also we write x belongs to a between a to b. From here we understand a is less than b, then we take, if b is less than, then we take firstly b, and after here we take a, okay. And second note point is if here given greater than 0, x minus a and x minus b, this one is greater than 0, then we take solution is here x belongs to minus infinity to open interval a. This is a minus a or plus b, this depends on our solutions. Open interval, because here we take open interval, here if here given equality sign, then here we take close interval. If here given equality sign, then here we take close interval, okay, this type. So in this expressions not given here equality signs, so here we take open interval union b to plus infinity. This interval we also write this type, means either x lying between this to this, means this type we write here also minus infinity to a, or we take b to plus infinity. This means this type we write. And the second point here, third point, in the same way take x minus a in the given this type in a modulus form or a square form. X square or mod functions behaves like that, same types of behave. If a square is less than, or this one we also write mod x is less than equal to a, then this type, for this type we write the solution here x is lying between minus a to, here is equal to sign, so here we take equality sign, x lying between minus a to plus a, okay, this type we write. Here a is less than b, this condition is always satisfied, then this type we write solution. Okay, if p is less than, then here we write b. If a is less than, so here we write a. This type is a solution. And in the fourth condition, this type, if this one is greater than 0, if x square is greater than equal to a square, or this mod x is greater than equal to a, then the solution of this one is this type we write in this second condition. Means x lying between minus infinity to this x and minus a. Here we take minus a, or x lying between x is greater than from a and less than to plus infinity. This one we also write this type. This one we write this type also. Minus infinity to minus a as open interval, because here not equality, here is equality sign sorry, then here we put equality sign, then here we take close interval, union, here we take close interval a to plus infinity. This is our solution. Okay, so now we take examples, questions. Now take here questions. Question is, first question, example number 1.28. Example 1.28 is, say that 1.28 example is, solve x square minus x minus 2 is greater than 0. Solve x square minus x minus 2 greater than 0. Okay, then solution of this inequality is, this gives this type. Now firstly we factorize this term in a factor type. So solution of this one factorize here, so we get x square minus x, so this is plus and minus 2x and minus 2 greater than 0. Firstly find here root. From here, help of this ones, we find here roots. So x plus 1, this is x minus 2 is greater than 0. Here inequality is given greater than equal to 0, so we take only positive intervals. Now we draw one real line number. This is a real line number. Here we draw real line number. Yeah, this time. This side is a plus infinity and this side is minus infinity. Here we take minus infinity. First root is a minus 1, so we take minus 1 here, and this gives 2, so 2 we take here. And in the rule, we know rule is, say first in a rightmost interval you put plus, so here we put plus sign, means positive. And now here we see at this root exponent of this one is here 1 and 1 is odd. Odd means change the sign from positive to negative. And exponent of minus 1 is, and exponent of minus 1 is, from here we see exponent is 1 here. 1 means this is a odd means sign changes from negative to positive. And here we in a final solution, here we see this inequality is in the greater than, means only we take positive interval. Okay, so here is positive, only we take positive interval, this interval and this interval. Here we take, here is not given in this inequality equal sign, so we take only open interval, not take a closed interval. So final solution is, therefore solution is this type. This side is minus infinity to minus infinity to minus 1 open interval, and union, this one is a positive interval. Here we take open interval up to this one. So this is my answer. Okay, any doubt here? No? If you have doubt, then comment in this comment section. Now we take second question. Question number 2, here we take question number 2 na. So here we write question number means example na. Here we write 1 point, hey 1.29 example is this one. He also say this question, solve x square minus x and minus 1 is less than 0. Okay, minus less than 0. Firstly we solve this inequality, this given expressions. This one is not possible for factorization, so solve this by this formula, root minus b plus minus under root b square minus 4ac, okay, divided by 2a. From here we get the solution is 2 root. Here we get 2 roots, and here we get 2 roots. So this expression we can write this type. Here we get 2 roots. First root is x equal to, this is 1 plus is 5 square root. So here we write square root 5 and divided by 2, and second root is 1 minus square root 5 divided by 2. This type we get roots. So this one now, so this equality we can write this type, x, this one is a minus, so here we write 1 by 1 roots 2, and from here x minus 1 minus square root 5 2 is less than 0. Now here we draw the real line number. So here we draw real line number, and this one we increase firstly because this is not in now. Here we write on the real line number these roots, this is a real line number, so we draw this type. This side is a plus and this side is a minus infinity. This one is a 1 minus now, so this is the smallest value, so this type we write x equal to 1 minus 5 root 2, and this side we take this one, here we take these roots, 1 plus square root 5 divided by 2. Now we write how in a rightmost, in a rightmost we put plus sign, here we put plus sign, why not change here sign color, yeah, and here we see exponent of this one is 1, so this is odd, so here we change sign from positive to negative, and this one have also exponent is 1, so this one is odd, so here sign is also changed. Now from here we take this one, this inequality is a less than now, here we see this inequality is a less than, so in the final solutions we take x equal to, so final solution is x equal to, x belongs to open interval because here not given equality sign. So here we write solution 1 minus 5 to 2 open interval 1 plus this one is here is a square root 5, here we also take a square root 5 divided by 2 and open interval. This is my answer. Okay, because here given this less than 0, so we take this interval, only with negative interval here we take. Now we proceed on next question. Our next question is question number 30. Here we read question number 30. Question number 30, here we write 1.30, and question 30 is given this type. Solve here x minus 1. What happened here? X minus 1, x minus 2, and another term is 1 minus 2x is greater than 0. Okay, why you go in background? Now here we solve the question. In a solution we write this one. From here we directly get the root get this one is 1, and from here we get 2, 1, 2, and from here get 1 by 2. Okay, this time we get roots. Now we draw real line. Here we draw real line. So when we draw real line, so real line number, this type we draw real line. Why slightly draw? Here we draw a real line. This type we draw real line number. This side is a positive plus infinity, this side minus infinity, and a smallest root is this one. So here we write a smallest. Now we write 1, and this side is a 2. Okay, now in the rightmost we take plus sign. In the rightmost here we take plus sign, and this one roots factor of this one have odd power, so sign here changed, minus, and 1 have also odd exponent, so here we sign plus we put, and this exponent here we say half root now. So here we write from this side also change the sign, so here we write minus sign, minus. Okay, now this one here, how we write the solution? So final solution, in the final solution we write therefore x belongs to, we take only positive interval, because here given a greater than means we take only positive interval, means this interval is a positive and not here given equality sign. So here we take in an open interval, right, 1 by 2, 1 union this interval 2 to infinity. Okay, this is my final answer now. Okay, wait, here we make mistake, firstly this one you changed in plus, all x writing in minus, so here we get different. Wait, yeah, firstly this is in a not a standard form, so this expression we write first in a standard form. And what is the standard form? All x have a positive sign. When we multiply this one we common out minus, so this change in 2x minus 1 now, means x minus 1, x minus 2, and 2x minus 1. This is a greater than 0, and here we take common out minus 1 here, and now we multiply 1 by both sides, so this expression changed in this type. Yeah. So this one is changed in this type: x minus 2 and 2x minus 1 is less than 0. Why less than 0? Because when we multiply inequality by negative number, then this sign is changed, the inequality sign is reversed. Okay, so from here with this one is a root for rightmost and the same is the interval. Here sign is the same. Now we take only negative interval, so this one is negative and this one is negative. So solution is, so therefore x belongs to minus infinity to half union for this one minus, so 1 and 2. This is the answer. This is the correct answer. Okay, before this one we take by mistakenly, not here, we carefully so make a mistake. Now we take another question, 31 number, and in a 31 yeah, now we read 31 questions. 31 number questions say that this type: 1.31 solve 2 by x less than 3. 2 by x less than 3. This one is not in a standard form, so we write firstly in a standard form and not multiply, not divide both sides. This one you comes in firstly in a variable side, take in a variable side. So with this type we write, when we subtract both side by 3, so we get this one. Now we take LCM, so 2 minus 3x divided by, here is a 3x divided by x less than 0. Now here we see this is in a x in a minus now, so we write in which form? Firstly we write in a positive, x all coefficient of x in positive, so this one change 1 by multiplying minus 1. So this one change in 3x minus 2 divided by x, and inequality is reversed. Why reversed? Because here we multiply by negative real number, means by multiplying by minus 1. Now we draw real number here. Here we draw real line this type. This side is a plus infinity and this side is a minus infinity, and we get root here. From here x not equal to 0 and 0, and from here we get 2 by 3, and here we see for this you don't take x equal to 0, so this one is open and this one also in open, because here greater than equal to 0. Now put in a rightmost plus and this side is a minus, because they have power is 1 na? Power is 1 means we write this one here, sign is changed negative, and this one is also positive, because x at x equal to 0, this one x minus 0, this one have also power 0, so here we write negatives from negative to positive sign. Okay, now we take this one is greater than 0, so greater than 0 means we take which portion only we take in a solution, we take only positive interval. So x belongs to from which interval? X belongs to from here and here, this side, means hey minus infinity no, minus infinity to 0 as open interval. Hey, what happened here? 0 is open interval union, and this side 2 by 3 to plus infinity. This is your answer. Okay, this is my final answer. Okay. Yes. Now we proceed on next question. Question number 32. Okay. It is question number 32. Firstly we erase this one. Now we take question number 32, 1.32, and 32 number question asked, you solve x minus 2 divided by x plus 2 greater than 2x minus 3 divided by 4x minus 1. This one we write, firstly we write all variable terms in a one side. So x minus 2, x plus 2, this one we take 2x minus 3 divided by 4x minus 1. This one we write is a greater than 0. Now we take LCM here. So this gives this type, x minus 2 into 4x minus 1. 4x minus 1 minus here is negative, right, 2x minus 3 into x plus 2 and whole divided by, in LCM what we get LCM of this one, LCM is x plus 2 and 4x minus 1, and this term is greater than 0. Say here we write greater than 0, here we put greater than 0. Okay, now this one we will solve, multiply and factorize here, this one multiply and factorize here. So we get, in the next line we get x and x, 4x square from x and here 8, 9x plus 2 into 1 is 2, and this gives minus 2x square minus x, and from here 3 to 6 and minus, and this minus, this gives plus 6, all divided by this one. Here we write in a, also this is in a factor, so not changing here, this one write as usual 4x minus 1, here is greater than 0. In the next step, this gives x square minus 5x plus 4 divided by x plus 2 and 4x minus 1. This is a greater than 0. Now when we factorize this one, so we get x minus 1 and x minus 4 divided by x plus 2, 4x minus 1. Yes, now we draw real line number, and here we get 4 roots, no? From here 1, 1 and 1 and 1. Total we get 4 roots. We get 4 roots, no? Hey. So this one we firstly clear. Yeah. Now here we get 4 roots, so we draw real line number. Firstly we draw real line number. This one is a real line number. This side is a plus infinity and this side is a minus infinity. Plus infinity and minus infinity. Now from here we get which root is lesser. 1 by 4 is smallest. Now minus 2 from here we give, now so minus 2, and we get 1 by 4 and 1 and this side is gives 4. Now I put the in a rightmost is a plus sign. Here is a plus. This one have exponent is odd, so minus. Here is plus, here is minus, and here is plus. We take greater than interval, no? Only we take greater. So final solution is our x belongs to, we take only positive interval, so minus infinity to minus 2 union this interval also contain plus, means 1 by 4 to 1, okay, and union rightmost interval is also contain plus sign, so 4 to infinity. This is our answer, okay, this one is our answer. Yeah, this one is a complete answer, okay. Now proceed on next question, and next question is here 33 number, na. Question number 33. Question number 33, she asked solve 1.33 question number. Say you solve this one. X is greater than from a square root 1 minus x, okay. Now here we take first condition. This one is defined only when defined. This one is greater than equal to 0, then a square root is defined. So here we take firstly in a solution 1 minus x is greater than equal to 0. This means we get when we add both side plus, na, so x is less than equal to 1. Yes, this is the first condition. And when we are squaring both sides from here on a squaring on both sides, okay, and we are squaring both sides, so we get x square is greater than 1 minus x. In the next step we take in the next line, here next line x square, na, x square plus x minus 1 is greater than 0, and from here this equation is not factorizable. Factorization is possible, so find the root here by the by the division formula. So here we get roots is x equal to minus b, means minus 1, plus minus, this gives 5 divided by 2. Here we get two roots. Now we draw here real line number, na. So here we draw real line number. From here to this side we draw real line number, yes. This side is a plus infinity and this side is minus infinity. And which root is smallest? Minus 1 minus root 5. So here we write minus 1 minus square root 5 divided by 2, and rightmost in 1 plus square root 5 divided by 2, and in a rightmost here we put plus sign, and this one have also contain one roots, no, so even power, odd power, so from sign is changed here from positive to negative, and this side is positive, and this one is a greater than 0, no, so we take positive interval. Wait, we take only positive interval. No, wait, this is a condition for this one, na. Here we take, wait 1 minute. Firstly this one we cancel, clear out in the below. and from here we get what is the solution greater than, so we take from minus 2. For this one, x belongs to minus infinity to minus 1 minus square root 5 divided by 2 union, and this side is a plus, so minus 1 plus square root 5 divided by 2, and this side is plus infinity. This one in a second condition. And now from 1 to 2, from 1 and 2, on comparing from 1 and 2 only we take common portion. So final solution is means final solution na, final solution is x belongs to, here you we compare in a first condition is x is less than equal to 1, x is less than equal to 1 matlab this side is minus 1 and this gives 1 point something, so this is divided by 2, this, so this gives 0 point something means, and this side belongs to 1, yeah, means this portion is common, and here equal to, this side here equal to. So from 1 and 2 here we get final solution is, my final solution is here, this side is open interval, this side, so minus 1 plus square root 5 divided by 2, and this side is a plus in a closed interval because x is less than equal to na. So this is my correct answer. Now I proceed on next question, question number 34. Yeah, now firstly this one we clean, yes, now we clean this one. Now we write here 1.34 question number, and question here asked you solve, I think this one is in some is complex problem. 2 by, question is 2 by x square minus x plus 1, and here is minus 1 by x plus 1 x plus 1 and here is minus 2x minus 1 divided by x cube plus 1, x cube plus 1 is greater than equal to 0, here is given greater than equal to 0. Hey, you go in a background now. Now here we know the formula, firstly we take this LCM, but here we know x1 plus 1 we can also write in 1 cube, so both are in shape, and a cube plus b cube formula is a plus b into a square minus ab plus b square. So this step, now here we see this one is contained here and this one is here, that means this term and this term in a denominator number, this denominator functions contain here, so we write in LCM, this one is our LCM, means we write this one. So when we divide, so this gives 2x plus 1, and here is minus, so here we put minus, we write separate formula, here we write minus, and here we get x square minus x plus 1, and here is minus 2x minus 1 all divided by, this one is taken LCM, x plus 1, then you solve, x square minus x plus 1 is greater than equal to 0. When we solve this one, so we get in a minus, so we get here in a minus in the next step when we calculate this one, so we get x square minus x minus 2 whole divided by this one. You also write in a factor form. So x square minus x plus 1, here is a plus 1 greater than equal to 0. This one is a negative, so this one is not in a standard form, and also this one is heavy factorize. So this one we write in a above.
No.
Yeah,
59
here we write
4620.
this one we will clean firstly. Yeah, so here we write multiply both sides by minus now, so this inequality sign is changed and also factorize here. So factorization here we get x minus 2 and x plus 1, x minus no sorry x minus 2, what happened here, x minus 2 and x plus 1 whole divided by x plus 1 into x square minus x plus 1, and inequality sign here changes, so this type we write. Now we get here two roots now, and this one we also factorize. This one is factorization is possible, not possible, so find by division method. Yes, so here we get total roots. One is here 1 roots, and here 2 means 1 and 2, and from here we get 2 roots, means here we get total 4 roots now. So firstly we draw here real line number. This side is a plus infinity and this side is a minus infinity. Okay, hey, why not here? This side is a minus infinity. Okay, which number is I think this one is now from here. This one is always give positive numbers. H here x square, this one is a plus and this one is a minus now. So this is the highest biggest and this one is minus, so this term making this one is a plus and this one is also plus, so this one is a positive, so this term we skipped because this not effect on sign, so we don't take for this one's root of this functions, only we take this one. Okay, x not equal to minus 1 because here x not equal to, when we take minus now then this is undefined, but this gives 1 minus 1 and this side is a, why not take here minus 1, because this term and this term are cancelled, this term and this term are cancelled, so we get only this this part here we left x minus 2 and this one is a positive, so you take also or not, so this one is not effect on your on our solution. So from here we get only one roots, only one root is 2, one root is 2, then how this type we write. These lines connect firstly, and here we take x equal to 2 and x equal to 2. When we solve this one means this side is a positive and this side negative, so we take only this part solution. Here equality sign mentioned, so this gives x less than equal to 2 na? So final solution is, our final solution is x minus infinity to h close interval. Yeah, this is my answer. Okay, now proceed in our next question, question number 1.35, and 1.35 is question say you solve in this way. Hey baba, Firstly clean this. Now take question 1.35. 1.35 na 1.35 question here given. This is a most wow beautiful question. क्या क्वेश्चन है x into x plus 2 and power is here 2 into x minus 1 and power is here 5 into 2x minus 3 and into x minus 3 power is 4. Here power is 4. Here power is 4 and inequality sign given greater than equal to 0. Now we solve this one. Firstly here find roots. Root can easily find because all terms given in a factor form. So directly we draw real number. This side is a plus and this side is a minus infinity. Yes. From here we get where negative, this one, this is minus 2 and then we take 0. Here is 1 and 2 by 3 by 2, this is 1 point something. So 1 and 3 by 2 and this is 3. In a rightmost we put plus and now here we see power of this one is this root's power is 4. Even means here sign is a stay. Sign stay means this one also maintain the sign, means sign not change from plus to plus stay. And 3 by 2, this is 3 by 2 and power is here odd. Odd means sign is changed. And now here we see x minus, this is 1, power is odd, so here sign changed plus and x is 0 na, and power is here odd. Odd means sign here changed. And this one have power 2 means even, so sign is stay. Now we take only greater than equal to 0. So my solution is x belongs to x belongs to, we take greater than interval na, so this one is positive, greater than na, but equal to in equal to we take close interval, means 0 is included in this interval and 1 here also include union. Here is closed interval 3 by 2 up to infinity na, so we take up to infinity. This is a final answer. Now we take question number 36. This one we clean or not clean. I have page na below, then why we clean. बउआ अरे भूल जाता नहीं हो, भूल गई छे. This question number is solve x into 2 to the power x minus 1, 3 to the power x minus 9 and x minus 3 less than 0. From here also we get easily find roots. This equal to 0, so x equal to 0. And from here 2 to the power x minus 1 equal to 0 na? So we get here x equal to also 0. So two roots have power is 0, 0 have 2 multiplicity, means power is x is even. From here 3 to the power x minus 9, this is equal to 0, so we get 3 to the power x equal to 3 square na? So we get here x equal to 2, and this side this gives x equal to 3. Now we draw real line number here. This type is not curve type na. So slowly we draw real line. Yeah, this is a real line number. This is a plus infinity, this side is a minus infinity. Now which roots is lesser? 0 is lesser than 2, then 3. Now I put the sign here. Put sign here. This side is a plus, and power of this one x to power 1 means sign here changed, and this side x equal to 2. This one is only one roots, and multiplicity is 1. So sign is changed, and here x2 multiplicity na, x to the power 2 0, so sign is not changed. Now we take this one is less than na, here is less than, so we take only negative interval, means this is open interval. So here final solution is our x belongs to, here is not equality sign given, so we take 2 to 3 in open interval. Okay, this is our answer. Yes. Now proceed to next question number 37. Here we write question number 1.37. Solve the inequalities. Solve the inequality x square minus x minus 1, and this side x square minus x minus 7 is less than 5. Is less than 5, minus 5. Now here we solve. Firstly this one we change in standard form, x square x minus 1 into x square minus x plus minus 7, and given minus 7, and this when we add both sides by 5, so this side give 5 less than 0, this side makes 0 now when we add plus 5 both sides. So now here we assume that because this type is solution is not possible for this is creating a complex, we solve but take more time. So for easily here you take this type given, so here we take this term x square minus x equal to y we take. Now here we put, so x square minus 1 in the place of put, and y minus 7 and plus 5, this is a less than 0. From here multiplying this one, when we multiply this, so this gives y square minus 8y plus 2 is less than 0. When we factorize this one, so we get y minus 6. When we factorize this one, so we write minus 6 and minus 2y, and y minus less than 0. From here we get, from the not point, this one is a less than, so we directly write x belongs to here we write, this is directly we can write plus minus in the middle between, means from here we get this is a y na, so here we write y not x. This implies this gives 2 to 6, here not equality sign equal, so here we not include equal sign. From here now we take 2 greater than, now we put value of y is x square minus x 6, and we take this one solve 1 by from here to here and from here to here we solve. We take this step and this step to inequality. So here we firstly take 2 less than x square minus x, and this side we take another inequality now. Yeah, firstly we this one we erase. And this side x square minus x less than 6. From this side we get here is a list space. So this one when we solve, left side x square minus x minus 2 greater than 0. When we solve this one, so in the left side we get factorize this one. When we factorize this one, so we get x minus 2 into x plus 1 is greater than 0, and this side this gives x square minus x minus 6 less than 0. When we factorize this one, so we get x minus 3 and x plus 2 less than 0. On this side we get this one is a 1. Where is 1? This side is 1 now. This side x belongs to from minus 1 to 2, and this side x lying between minus 2 to 3. And from here this one is a 1 and this one is 2. From 1 and 2 we get final answer is
30.
From 1 and 2 we get here final solution is common solution. Minus 2 is lesser, but here minus 2 absent, minus 1 here is absent, this minus 1 is here present. So x belongs to minus in an open interval. How we write this one? Solution, you take what's the question solved now? So common value of this one, this side we write in a wrong way. This side is less, no? So we take negative interval, but positive interval. यहाँ तो make mistake किए हैं. This side we make mistake. This side we make mistake here. Wait. When we draw real number, na, when this one we write, this one is greater than, then we write different type. Now this one is less than, so this is a true. But when this is greater than 0, then we take infinity part, na. So x belongs to minus infinity to 2 in an open interval union. Oh, this side is minus 1. This side is a minus 1 union. This side is plus 2, na. This is plus 2 up to infinity. Now we take common solution. This one is 1. This one is first equation. From 1 and 2, here we take minus 1 minus infinity to 1. So minus 2 here contain minus 1, minus 2 to minus 1. So minus 2, minus 2. Here we write minus 2 to minus 1 and union. Rightmost interval contains from 2 to 3. Union 2 to, here we write 3, 2 to 3. This is a correct answer. If anyone have doubt, then you comment in the comment section where you have doubt. We are present for your clearance. Okay. Now, what time? In the next session, we solve unsolved question 1.3 exercise. Okay, concept of application.